do you have any questions for me before we start? Any comments, any issues, homework? Yeah, so as I always say, please feel free to reach out if you don't understand anything, right? Don't wait till it piles up. If you don't get anything, you have me, you have your TAs, you have like Math Center, which allows like free walking tutorials and stuff. So please make use of all the opportunities available to you. Okay, so if there are no comments, let's get on to where we ended off the last time. So for some time now, we've been looking at some differentiation rules, right? We started with 3.1 where we learned about 5 of them, right? Five of the rules. And then in 3.2, we are adding to the list. So in 3.2, we looked at the product rule, and then the last thing we looked at was the quotient rule, right? So we are basically going to apply the quotient rule in our next example, right? Oh, I'm sharing my screen. If you can't see, do let me know, right? So we said if you are trying to find the derivative of a quotient of functions, which is d over ds or f of x over g of x, then it's just, you can use this mnemonic to help you remember, right? So low d high minus high d low all over square of what is b low, right? So the low function is just maintained, multiplied by what? The d high, that which means the derivative of the top function, and then minus what? High, which is the top function, d low, right? The derivative of the low function, and then all over what is the square of what is b low, right? So square what is in the denominator. Now we prove this formula here, and then other thing we're looking at was this example, right? So let me come here. They've started this for us, but since they have the example here, let me move to the whiteboard. So we have example 4. So this is 3.2. We're looking at example 4. This is example 4 on the slides. So in this example, we are given a function y equal to s squared plus x minus 2 over s cubed plus 6. I think, let me erase this because this one will be, I'll probably need more space here. Yeah, and then the question is asking for y prime, right? So let's try and find y prime. So in order to find y prime, what do we do? Well, we know that y prime is just the derivative, right? It's just the derivative of y. So just attach the differentiation operator to the y function. So we have s squared plus x minus 2 all over s cubed plus 6, right? So then we run through the rules. Let's look at this expression we have here and think about it. Is this a standard, like a derivative of constant? No, this is not any of the, is it a sum, derivative of sum? No. Is it a derivative of, no. Oh, but I see that this is a quotient. This is a function over another function. So immediately it clicks. I'm going to use the word, the quotient rule. So what is the quotient rule? Low, what is the low? Is the whole thing in the denominator, right? So the low is s cubed plus 6, d high, so that means the derivative of what? What is on top here? S squared plus x minus 2. And then minus high, the high is what is on top, right? So that's s squared plus x minus 2. And then d low, so the derivative of what? What is in the denominator? So that's s cubed plus 6. All about square of what is below. So that's what? The square of what? S cubed plus 6, like so. Please, I hope you're okay with the setup. If you don't understand, do let me know. The setup, that's the very important step. Okay. So after you get this, you focus on where the differentiation operators are attached, right? So for this one, I'll ignore the SQ plus 6 since that one is just that function, right? And then just get rid of the one with the differentiation operator. So just focus in this one. And then for this second term, I'll also be focusing on this, the last piece, right? So let's continue with this. So I'll just repeat the SQ plus 6. And now let's get the derivative of this thing here. So let's just zoom in on this. Now, this is a sum and a difference. So if you are trying to take the derivative, you can do it 10 by 10. So we try and take the derivative of s squared. And what's the derivative of s squared? So we run through the rules. Derivative of s squared. Oh, that's a power function. So that's the power rule. So what does the power rule say? The power rule says, okay, maybe let me make it more interactive so you guys can help me out. Please, guys, for the derivative of s squared, what do we get for the derivative? What do you say? Help me out so that we can practice. Okay, I have 2x. Perfect. Thank you, guys. Yeah, thank you. Perfect. That's correct. So the derivative of s squared is 2x. So we just write it here. What about the derivative of x? No, that's okay. Yeah, feel free to speak your mind. If you make a mistake, that's fine. Even with a typo too. Yeah, so derivative of x, I have 1. Okay, anybody else? A different answer? Okay, I have 1. I have a second. Okay, that's true. The derivative of x is just 1, right? Now, what about the derivative of 2? What's the derivative of 2? That's a constant, right? The derivative of 2 is what? 0. Perfect. Thank you. Thank you, right? Yeah, so that's 0. So I can decide not to write that, right? And then minus s squared plus x minus 2. And then let's look at the derivative of s cubed plus 6, right? What's the derivative of s cubed? Anybody? What do you say? What do you say? What do you say? Derivative of s cubed. 3s squared. Okay, 3s squared. Yeah, perfect. That is true. So that's a power rule, right? So that would be 3s squared. And then what the derivative of is? The derivative of 6. Yes, derivative of 6. What's that? Are you sure? Okay. Overwhelming 0. Yeah, that is true. That's 6 is a constant, so that's it, right? Now, talking about this, the fact that 6 is a constant, let me make a side note here. Guys, what's the derivative of e to the 5? Okay, so I have e to the 5. E to the 5, a different answer. Okay, still I have a second. Okay, so I have a scanner to this. But the derivative of e to the 5 is 0. Don't forget that e is a constant, right? So if it's e to the x, then the derivative of that one is not a constant. That's a variable. The variable depends on x. But here, for e to the 5, it's e to the 5th power. So that is a constant. A constant to a power is still a constant. So that is 0. So just note that. You may meet it at some point. So that's just a side note, talking about constants. Okay, so now, then the denominator, we have s cubed plus 6 all squared. Now, when you get here, you are done, right? You can leave your answer here, right? Weber-San will accept it. I will accept it on an exam, right? So when you are here, you can just type this in. The Weber-San will say you are right. As I said, when we get to chapter 4, there we will simplify. That place is where we do the simplification. So by here, the focus is to learn how to differentiate. So after the differentiation operators disappear, you are done. That's your answer. You can put it in Weber-San to accept this. Yeah, and that's all. But if you still want to simplify too, that's good. But we see more simplification on the PowerPoint. So, but no matter what happens, please do not simplify the denominator, right? Do not simplify the denominator. And that's all on this. That's the quotient rule example. Please, any questions here? Anybody needs time here? Okay, so that's the quotient rule. So low D high minus high D low, all over square of what is P low, right? So now this one has nice notes. As I always said, don't copy everything. A lot of the notes are already on the PowerPoint, which I'll post. And then the ones, even the ones I'm writing to, I'll post. So yeah, that's just about. So this one just going to go through the rules, right? So quotient rule applied. And then we get here, and you see it simplified the top a bit, but it left the denominator low. But as I said, when you get to this part, you are right. You are correct at here. You are correct here. You don't need to simplify. And that's all. Okay, so now let's move on to example 5. I think this one I have space here. Yeah, the solution is not on here, so let me work it here. So this one says, find an equation of the tangent line to the curve y equal to e to the x. Why don't we simplify the denominator? Now, when we get to chapter 4, that's a good question. So I think someone is asking why we don't simplify the denominator. When we get to chapter 4, when we start to write everything in a simplified form, usually the denominator sometimes cancels out some common factors on top. And you need it in factored form to cancel those out. That's the motivation why I said do not reduce the denominator. Yeah. Okay, cool. So now we are here, right? So let's try and figure this out. This one says find an equation of the tangent line to the curve y equal to this at the point 1/2 e. So the question is, to get the equation of any tangent line, you need two things. You need a slope and you need a point on the line. Now this is the point on the line that is given. So all that we have to do is to find the slope. So that means for the slope, we need f prime at what? At 1. This is the x value, right? This is the a f of a, right? So we need f prime at a, which is f prime of 1. So f prime of 1 is just find f prime of x and then evaluate it at 1, right? Find f prime of x and evaluate it at 1. So let's start with f prime of x. So for f prime of x, just attach the differentiation operator to the e to the x over what? 1 plus s squared. That's the first step, right? So we are trying to get f prime and then we plug in 1. Okay, so now let's reason around this. Oh, is this a sum of functions? No, it's none of those, but this is a quotient. So immediately, oh, quotient rule. So by the quotient rule, what do we do? Is low d high minus high d low over square of what is what? B low. Like so, right? And then let's try and get rid of the differentiation operators and by applying the derivatives, right? So what's the derivative of what? E to the x. The derivative of e to the x is just what? So we have 1 plus s squared. The derivative of e to the x is just e to the x. And then we have minus e to the x. The derivative of 1 plus s squared, the derivative of 1 is 0, and the derivative of s squared is what? Is 2x. Right, so just 2x like so. And then all of what? 1 plus what? S squared, all squared. So then we have the what? The derivative. Right? We have the derivative. Okay, now at this point, you can just find the what? The slope. Right? So the slope will be equal to what? The slope will be just be f prime of 1. So let's just plug 1 in here. So that would be 1 plus 1 squared e to the 1 minus e to the 1, and then what? 2 times 1. All over what? 1 plus 1 squared, all squared. Please, I hope you follow. Any questions up to this point? Okay. Now, for this one, 1 plus 1 squared is just 2. So that's 2e minus what? And then this one is 2 times 1, which is 2 times e. So that's also 2e. And then all over, that's 1 plus 1, that's 2 squared. Right? But 2e minus 2e is what? Is 0. So that means the slope is what? The slope is equal to 0. Please, are you okay with this? Any part you don't understand that you want me to go over? Okay. Anybody needs a brief time here? Okay. So we have the slope to be equal to 0, right? This is the slope. And we have the point. Okay, wait, I see something. So the derivative gives you an equation, and then you plug in sy into the equation. Yeah, so the derivative will give you, an expression, right? It will give you an expression, it will give you a constant. But when you get the derivative and you evaluate it at the point, then you get the what? The slope of the tangent. Don't forget that the slope is the derivative evaluated at the point. Yeah. Do you see? Yeah. Yeah. Okay. So we have the slope and then we have the point. What's the point? 1/2 e. 1 and then half e. So let's just proceed and get the equation of the tangent line. So what's the equation of the tangent line? We use the point slope formula. So that's this my x1, this my y1. So the equation will be y minus y1. So that'll be half e equal to what? The slope, x minus what? x1, which is 1. So this 0 and that will go off. So we just have y equal to what? Half e. And that's my equation of tangent line. So let me say equation of tangent line. Okay. Please, any questions here? Is there any part you don't understand? Feel free to speak your mind. Let me know what's going on. Okay. Anybody needs time here? Oh, okay. You need time. 1 sec. Okay. You got it. Perfect. Perfect. Thank you. Yeah, you're welcome. Okay, so now let's move on to the next part. Now, this is the last set of examples we're going to see for this section. So far, we're going to practice all that we've done, right? So let's look at this. So for A, so as I said, please memorize the rules, right? You are not allowed a formula sheet from the department. That's from the department. That's the instruction. You guys are not allowed formula sheets on this. So it would be a good idea to memorize all of these, right? And don't wait till it piles up, right? If it piles up, it may become overwhelming. Okay, so now let's do this. Now the preamble says you're giving f of 4, you're giving g of 4, you're giving f prime, you're giving j prime. And then each of these are evaluated at 4, right? And then the question is asking for h prime of 4. So for this one, in order to get h prime of 4, for A, we know to get h prime of 4, you just need to find h prime of x. And after finding h prime of x, we can just plug in the 4 and get h prime of 4. So h prime of x, what is that? So that's just going to be d over dx of what? Attached to that expression. So that's 3f of x and then plus 8g of x, right? So let's see what is going to happen here. Well, the differentiation operator is linear. So when we have addition, the derivative of sum is a sum of the derivatives. Wait, if you put an unsimplified point slope, you would it be okay? So the unsimplified point slope. Oh, okay. You mean this one? I'm not sure. It will. Usually, if it says, I think it accepts. The last thing I checked, I tried one example and it worked. But usually, when the WebAssign does something like this, if it has the y equal to already outside, so let me do this on the side. You have the y already equal to on the outside, and obviously you have to simplify to plug it in here. But if it just gives you a big box like this, then I think the point slope formula will also work directly. But either way, you can just try that one directly, or yeah, I think it should work. Yeah. Okay, so that's it on that. Yeah, you're welcome, Hunter. Yeah. So now let's go back to the example we're looking at. So we need h prime, right? So I attach the differentiation operator to the expression, and then I go through the derivative. Now for this first piece, I know I'm doing a derivative of a sum, right? The derivative of a sum is the sum of the derivatives. So I can just do it 10 by 10. Now looking at the first term is 3 multiplied by f of x. So 3 is a constant, and then the f of x depends on x. So that means I can use the constant multiple rule, ignore the 3, and do the derivative of f of x, which is just f prime of x. The same with the second piece. So that would be constant multiple rule, and the derivative of g of x, which is g prime of x. Please, I hope you're okay on this. Okay, so now with this one, if you want to find, now that you have an expression for the derivative, if you want to find h prime of 4, you just plug in 4 wherever you see x. So that'd be 3 f prime of 4 plus 8 j prime of 4, right? And then the f prime of 4 and j prime of 4 have been given here, up here, right? F prime of 4 is 6, j prime of 4 is -3. So that means you get 3, f prime of 4 is 6, and then plus 8, j prime of 4 is -3, right? So what is that? So these will give you, so that's 3 times 6, which is 18. And then this one is 24, so that minus 24. So that'll give you 18 and minus 24, that's -6. Oops, it just went to the next slide. So that'll be -6, right? And that'll be your answer. Please take note of this example, right? I mean, you meet them on the exam, on the assignment, and you may also meet them on the exam, right? So take note. Okay, so now let's go to the next one, h prime of x. So to get h prime of x, you just do d over ds of what? F of x times g of x. So for this one, we run through the rules and we realize that this is just a product of functions. So we can employ the product rule. So the product rule says leave one function alone, multiply by the derivative of the second function, plus what? This time switch rules. So this time leave g of x alone, multiply by the derivative of what? The first function. So that's the product, right? So if you want h prime of 4 for this case, then it's just going to be f of 4 times j prime of 4, right? Plus g of 4, and then times what? F prime of 4, right? So what will this be? Well, wherever we see for the f of 4, all those things have been given in the preamble. So let's just plug those in, and then you see what you're going to get, right? So for the f of 4 is 2. J prime of 4, J prime of 4 is what? It's -3. And then plus, what's J of 4? J of 4 is 5. And then F prime of 4, what is that? F prime of 4, F prime, that's 6. Right? So putting everything together, you have -6 and then plus what? 30. So that'll give us 24. So that's our answer to that one. Okay. Please, any questions so far? Feel free to let me know. Right? Okay. Now let's get to C, h prime of x. So that one, we just attach a differentiation operator, d over ds of what? F of x over g of x. Right? So that'll be the quotient rule, right? The quotient rule, because the quotient of functions. So by the quotient rule, it's going to be a low d high, low d high, so f prime, minus high, so that'll be high is what? F of x, d low, that'll be j prime of x, all about the square of what is below. So like so. So if you want this, the h of 4, right? Sorry, h prime of 4. Let me write that down here. So h prime of 4 will be equal to what? So that'll be g of 4. This 2. Give me a sec. Let me try and create some room here. Okay. Draw, erase. Okay, so let me make some room here. Okay, so as I was saying, h prime of x will just be of d over dx of f of x over g of x, right? So that will just be low, d high, minus high, d low, over square of what is below, right? So if you want h prime of 4, then that's just going to be g of 4, f prime of 4, minus what? F of 4, g prime of 4, over what? Over g of 4 all squared, like so, all squared, yeah. Right. So now let's just pick the numbers and plug them in. So what's g of 4? G of 4 is 5. So read that here. And then f prime of 4, what is that one? F prime of 4 is 6. Okay. And then minus f of 4. F of 4 is 2. And then g prime of 4, what is that one? Negative 3. And then all over square of what? G of 4. What's g of 4? G of 4 is 5. So that'll be 5 squared. So putting everything together, for this side, you have 5 times 6, that's 30, right? 30 minus 2 times 3, that's 6. So that's 36 over square of 5 is 25. And that's our answer. Please, are you okay with this? Any questions? Okay. Anybody still needs time here? Are you all okay? Okay. Let me wait for some seconds in case someone's taking notes. Looks good. Okay. Okay, cool. Okay, then let's move on. Okay, so then let's move on to the last example, right? So for this one, we need h prime of x, right? First, and then afterwards, we just get h prime of 4. So we just attach the differentiation operator to the expression. So you have g of x over f of x plus g of x, like so, right? So the question is, running through the differentiation rules, which one applies here? Well, I can see that this is a quotient of functions, right? So I say, okay, then the quotient rule will apply. So the quotient rule says low. So what is low here? The low is the entire function here. The low itself is a sum. So low is what? F of x plus g of x. D high is just g prime of x. Minus high, g of x. D low will be what? The derivative of what is down here. But the derivative of a sum is the sum of the derivative. So that'll be f prime of x plus g prime of x. Right? All over square of what is below. So that'll be f of x plus g of x all squared. So that's the derivative. So if you want h prime of 4, then that'll just be what? F of 4 plus g of 4, and then g prime of 4 minus g of 4, and then f prime of 4 plus g prime of 4, and then all over what? F of 4 plus g of 4, and then all squared, like so. So moving on, I have h prime of 4. So then I just pick my numbers and plug them in, right? So what's f of 4? F of 4 is 2. So that'll be 2 plus, what's g? Let me do the f of 4. There's one down here. Let me put it in directly. Now, what do I need? G of 4. So what's g of 4? G of 4 is 5. So 5 is here, squared, 5. And then g prime of 4. G prime of 4 is negative 3. Negative 3. And then minus g of 4. G of 4 is 5. So pick my numbers there. And then f prime of 4. F prime of 4, where is that one? That's 6. And then plus g prime of 4. G prime of 4 is negative 3. So plus negative 3. So what do we get? Well, this one is just going to be 2 plus 5 is 7. And 7 times 3 is negative 21, right? Times negative 3 is negative 21. And then here we have 6 minus 3, which is 3. And then 3 times 5 is 15. So we have minus 15. And all over. That's 7 squared, which is 49. So h prime of 4 is therefore equal to what? Negative 21 minus this will give us, that would just be negative 36 over 49. And that would be our final answer. So please, I hope you understand how we approach these questions. Do you have any issues here? And this is the last example on this section. We are done with 3.2. Any questions? How did the f become prime? The f become prime. Okay, I'm thinking the only f prime I see is in this side, right? So for this side, how the f became prime is like this, right? We are using the quotient rule. So the quotient rule says low. So the low is a sum. The low itself is not just a direct function, right? It's a sum of functions. So low, so that's why we repeated the low here. D high, so the D high is for the derivative of the top here, which is J prime. Minus high, so that then the high is J of X, so just J of X. D low, so we are going to do what? The derivative of what? What is low, right? But the derivative of low is a sum. Do you see? It's a F of X plus J of X. So if you want to find the derivative of that sum, what's the derivative of a sum? It's a sum of the derivatives. So that means that we get what? F prime plus J prime. Please, does that make sense now? Or are you okay now? Yeah, you got it. Perfect. Okay. Please, any other questions here? Anybody needs time? Okay. So this is just giving us a recap of all the rules we've learned. And as I said, it would be a very good idea to try and start memorizing them right away. The derivative of a constant is 0. The derivative of what? S to the power n is just what? The power rule. So bring the n in front, subtract n from the power. The derivative of e to the s is e to the s. The derivative of a constant times some functions, or the constant times the derivative of the function. The derivative of a sum of functions is what? Is the sum of the derivatives. The derivative of a difference of functions is a difference of the derivatives. The derivative of a product of functions, by the product rule, leave the first function alone, multiply by the derivative of the second function, plus what? Leave the second function alone, multiply by the derivative of the first function. And then the derivative of a quotient, we employ the quotient rule. So that's low D high minus high D low over square of what is B low. So that's what you see here. So this is just a table of what we have so far. Please, any questions here? Okay, anybody needs time? Okay, so that's the end of 3.2. So the ideas were product rule and quotient rule. Let me save this. The PC is a bit slow today. I don't know why. What's going on? So let me see 3.3. Okay, so now we are here on 3.3. So now for 3.3, we are going to look at the derivative of trigonometric functions. So for trigonometric functions, you see some of the trigonometric functions you are familiar with are sine, cosine, tangent, cosecant, secant, and cotangent. So you're going to see how to get a derivative for each of these. Now, don't forget that for trigonometric functions, the building blocks for all the kinds of trigonometric functions you have are sine and cosine. The building blocks are just sine and cosine. You can use sine and cosine to build each of these, right? So the emphasis will be to develop the derivatives for sine and cosine, and then we have the derivative for the rest, right? You'll be able to get a derivative for the rest. So we start with sine, right? We start with sine. Now, looking at sine, look at this graph. So sine is the blue curve here. So we have y equal to sine of x. Now, using the technique we learned the last time, how to obtain the graph of the derivative from the graph, you check the slope of the tangent along the line, right? So that's the plot here, right? That's the plot you see underneath here, right? So at this point, it touches the x-axis. That's why it touches here. And at the turning points, it touches. So that's why you see it touching here and there, right? And then for the other sides too, you see they have this here showing that it's becoming more and more negative. At some point, it becomes less and less negative and it becomes 0, right? So that's what you see here, right? Now, looking at this derivative, you can suspect that, looking at this guy, the derivative down here looks like cosine. But it's not actually like a concrete way of saying that the derivative is cosine just by observing this, right? But you can kind of get an idea that it looks like cosine. Well, let's see if it is cosine, right? So that's what we're going to prove. So to prove that, we need to use the definition of a derivative, right? We're going to use the definition of a derivative. So let me do that on the side. Let me do that on the whiteboard. The solution is here. So let's do that on the whiteboard so that at least we practice something. So we have f of x equal to what? Sine of x, right? So we need f prime. So we start with f prime. So what's f prime of x? Well, f prime of x is limit as h approaches 0 of what? F of x plus h minus f of x all over h. So we have limit as h approaches 0. What is f of s plus h if f of s is sine of x? Well, it's just sine of s plus h minus sine of what? X all over what? H. But then from your math 127, right, you learned that if you have sine of a plus b, then what is this? That's just going to be sine of a cosine of b plus what? Cosine of a, or let me use sine so that I repeat just the same pattern. So it's the same as what? Sine of b cosine of b. No, cosine of a rather. Yeah, I already have cosine of b. Right, so that's for math 127. So using this idea, that means you can what? You can break this piece down for the sine of s plus h. You can break that down into what? Sine of x cosine of h. And then plus what? Sine of h cosine of x. And then you have minus sine of x right here. And then all over what? All over h. Please, I hope you're okay up to this point. Any questions? Okay. But then you realize that there are like terms here. You see sine, if you want to factor, you see sine of x term here, and you see another sine of x term here. So let's group those two, right? So we have limit as h approaches 0. Well, if I group those two, I can write this as sine of x, and then, so factor sine of x out, and I have cosine of h minus 1, and then plus what? Sine of h cosine of x, like so. So this one is over h, that one is over h. So you can have this, right? So I group these two, this one and that one, and factor out the sine of x, so that what is left here is cosine of h, and what is left here is 1. And then what is left is what the remaining term is sine of h cosine of x, which is what you see here. And then I distributed the h to each of them, right? Okay. Please, any questions up to this point? Let me put these in parentheses so that you see the limit applies to the two. Now, at this point, the limit of a sum is the sum of the limits, right? So you have f prime being equal to what? Now, for this piece, if you're going to do the sum of the limits, if you're taking the limit as h approaches 0 of this expression, note that the sign of x does not depend on h. So that means it's behaving like a constant. Hence, you can factor it out by the limit rules, right? So you can just factor out sign of x here. And then you have limit as h approaches 0 of cosine of what? H minus 1 all over h. And then plus, for this piece, because cosine of x also does not depend on h, you can also factor that out. You have cosine of x, and then the limit as h approaches 0 of sine of h all over h. Please, are you okay up to this point? Any questions on this proof? As I always say, I'm not going to ask you about any proofs, but some of you, depending on your majors, you may need to see some of these, right? To kind of like boost your proofs for calculus. You may need it at some point in your career. For others who won't need it, it's also good to see that the formulas were not conjured. They all make sense. They all add up. They all add up. We didn't just pull this out of anywhere, out of thin air or something. Yeah. Please, any questions up to this point? So I'm here. So that means that in order to figure this limit out and this derivative out, the two expressions that come in very handy, or the two limits that are very important to figure out, are this limit and that limit. If I'm able to find these two, then I have the derivative of sine of x. Right, so I'm going back to the PowerPoint and then show you a numerical analysis they did on that. Right, so the notes are just showing what I just showed you. Right? But I don't want to just slide through the slides. I need us to practice and work some of these things out. Yeah, so it falls on these two. Okay. But then, as you can see, if you have, say, sine of x over x, looking at the numerical evidence, I mean, there's a geometric way of proving this, but you're not responsible for that. The numerical evidence is sufficient for this course, right? So looking at this, if you let, say, x approach 0, in this case, there's a conflict between the theta and the x, but just know that the x is representing theta here, right? So if we let this approach 0, right, because you're taking it closer and closer to 0, then the sign of s over s is becoming something like 0.999999983. So that means that this limit is what we can take a wild guess and say this is 1. And this is true. It can be proven geometrically. But as I said, we're not responsible for that in this class, right? So we know that limit or sine of theta over theta as theta approaches 0 is 1. So this is valid, right? So we have one piece for the two limits that we need, right? Now we can use this to get the limit for the other one. So we are looking for this and then this other one. So cosine of something like cosine of theta minus 1 over theta, right? So that's the second one we need to figure out. So for that one, we come here. For this one, I'll just show you, and then I'll apply the rest on the whiteboard. So for this one, let's try and get this limit. So we have limit as theta approaches 0 of cosine of theta minus 1 all over theta. Well, if you plug in 0, you see that cosine of 0 is 1, right? If you plug in 0, cosine of 0 is 1 minus 1 over 0. So you get what? 0 over 0. This type 0 over 0. Now for trig functions, when you have the type 0 over 0, for this case, you can what? Kind of like do some kind of multiplying by the conjugate, right? So in this case, you can just multiply the top by cosine of theta plus 1 and then divide by cosine of theta plus 1. I've not done anything to the original expression because I can just cancel out the cosine of theta plus 1 and cosine of theta plus 1. And I return back to this, the cosine of theta minus 1 over theta. So nothing changed. Nothing has changed, right? Nothing has changed. But then looking at the top, right, I can multiply them out and get cosine squared of theta minus 1 and then all over theta times cosine of theta plus 1. But then cosine squared of theta minus 1, note that in your calculus classes, you said sine squared of theta plus cosine squared of theta is 1, right? So that means that cosine squared of theta minus 1 will be what? Negative sine squared of theta, right? So if this is that, if this is 1, then that means cosine squared theta minus 1 is what? Negative sine squared theta. So that's how come they got to this part, right? The denominator is still repeated. Now, when you get here, don't forget that sine squared of theta is the same as sine theta times sine theta. So we can break this piece out. First factor out the negative here is out here. And then break this out into sine theta over theta. So the first sign is taking this, right? So sine squared theta is sine theta times sine theta, right? Sine theta. So if you factor out the negative, you have the negative out here. And then you have sine theta all over theta times cosine theta plus 1. So you can kind of like give each of these signs to what? One piece of the denominator. So that's how come you have sine theta over theta. And then times of sine theta over cos theta plus 1. Please, are you okay up to this point? Any questions? Up to this level. Up to this level. Okay. Now, the motivation for doing this split is so that we can apply the limit rule that the limit of a product of functions is what? Is a product of the limits, right? So if the limit is this, so we take the first limit, right? So the limit of this piece times what? The limit of the second piece, right? So that's why you see the negative is still waiting out here. You have limit as theta approaches 0, sine of theta over theta times what? Limit as theta approaches 0, sine of theta over cos theta plus 1. But the thing is, this is something we've already figured out by the numerical evidence up there. This one is what? It's 1, right? So that's how come we have negative 1 here. And then for this piece, we try plugging in again. So if you plug in 0 here, you get sine 0 over what? Cosine 0 plus 1. But cosine 0 is 1. So in the denominator, you get 1 plus 1, which is 2, right? So for this piece, you're going to get what? Sine of 0 over cosine of 0. Oh, no, not theta, 0 plus 1. And then sine of 0 is 0, cosine of 0, cosine of 0 is 1, and then 1 plus 1 is 2. So you get 0, right? So that's how come you have this, right? 0 over 0, 1 plus 1. So the whole thing will give you 0, right? So that means that this limit, this special limit is what? Is 0. So we've been able to find these two limits, right? Which are important here. Now, let me emphasize here. Now, for this section, the limits that you'll be employing, the only limits you'll be seeing on the exam or any part of the test on this limit will be based on these two limits that I just talked about. Any limit questions you'll be dealing with will be based on these two, if it's involving trig functions. So these are very key. You must memorize these as well. You become very, very important. right? So limit as theta approaches 0, sine of theta over theta is 1. Then limit as theta approaches 0, cosine of theta minus 1 over theta is 0, right? So just note this. Now we have the two limits, right? We have the two limits that we needed. We have one to be 1 and the other to be 0. So let's go back to the whiteboard and then wrap up the proof, right? So let me come here. So we know that this one is 1 and then this one is 0, right? So that means that we have f prime of x to be equal to what? To be equal to sine of x times 0, and then what? Plus cosine of x times 1. So what do you get? That means you finally get, this one will go to 0, so you get cosine of x. So this confirms the graph that we saw, we noticed up there, that the derivative of sine is just cosine, right? So don't forget this. So the derivative, let me write that down here. So the takeaway is the derivative of sine is cosine of x. So that's what we get. Okay, please, any questions here? Okay, so I've shown you for sine. Cosine will play out in a similar way, right? It will play out in a similar way. So let me show you that. If you need time here, let me know, like a brief time. If not, I'm going to the PowerPoint. Okay, so now let's check out cosine, right? So we've established that the derivative of sine is cosine, right? Very important. Oh, okay. First, they give you an example before you go to cosine. Okay, so now that we have sine, let's just do this. Let's do this derivative. Let me do example 1. At least we have for sine. So let's try one example. Good idea. So this example 1. So this, you are still on 3.3. I hope I had that note here. Okay. So this on 3.3 slice. Okay, so we have y equal to s squared sine of x, and you're asked to find what? Y prime. Right, so let's get y prime. So y prime will just be what? So attach the differentiation operator to the expression. So s squared sine of x, like so. And then the question is, for this expression, do I have a direct differentiation that will give me the answer directly, like straightforward? No, I don't have any differentiation formula, which is like s squared sine of x. Okay, let me think. But then, what do I say? Is this a sum of functions, a difference of functions, or a product of functions? Well, you can see it's a product of functions, right? It's s squared times sine of x, two things multiplying. So what do we do? Well, it's a product of functions. So as the name implies, we employ the product rule. So by the product rule, leave the first one alone, multiply by the derivative of the second, plus leave the second function alone, multiply by the derivative of the first. Now, the derivatives that we see here are kind of like things we can recognize that they are standard, right? The derivative of sine is what? We just figured that out. Let's just cosine plus sine of x. And the derivative of s squared, power rule, 2x. We are done. You can stop here. That's your answer. Or you can simplify further. Doesn't matter. Okay. Please, I hope you understand this. Any questions? Okay. Anybody needs time here? Brief time here. Okay, then let me go back to the PowerPoint, which will have nice notes, right? So the notes are here to explain everything. So product rule, so you spread it out and then you differentiate and you're done. That's all. Now, we are not going to do the proof for cosine. It follows the same pattern as the sine. You can do if f of x is equal to cosine. You can try this yourself if you want, right? So you can try. Use the definition of a derivative, like f prime of x equal to the limit as h approaches 0 of, so in this case, we cosine of s plus h minus cosine of x all over h. You can try this if you're interested in the proof, which would be kind of cool to derive. Yeah, but when you use this proof, you're going to get what? Negative sign. Negative sign. So the derivative of the derivative of sine is what? Is cosine, but the derivative of cosine is negative sine. Okay, so we've established two. Now, because we've established these two, we can get all the other ones. All the other ones. For example, if you want the derivative of tangent, what is tangent? Tangent of x. Tangent is just sine of x over cosine. So that's just what? The quotient rule. Right? This sine over cosine. So quotient rule. So by the quotient rule, what do you have? Low d high minus high d low over square of what is b low. So low cosine, d high, d over ds of sine, minus high minus sine, d low, the derivative of cosine, over square of what is b low. So that's cosine squared. And then what's the derivative of sine? It's just cosine. The derivative of cosine is negative sine. And then cosine times cosine is cosine squared. And then negative sine of x times negative sine of x is positive sine squared. All about cosine squared of x. But then cosine squared of x plus sine squared of x is 1. Right? So that means we get what? 1 over cosine squared of x. Right? So note that's sine squared x plus cosine squared is 1. So we get 1 here. And then for this piece, note that if you have 1 over cosine of x, then that's just the secant of x. Right? So that gives you what? So 1 over cosine squared of x is the same as what? 1 over cosine of x all squared. Right? And this 1 over cosine is secant. Right? So that gives us what? Secant squared of x, like you see here. Yeah. Please, any questions on this proof? So that's 3 rules down. Let me say 4 because let me say 5 because those 2 limits are also important. They'll come to play at some point. Please, any questions? Okay, so I'll entreat you to probably go through deriving it for each of these, but we're not going to do, at least you have seen how we did it for tangent. We're not going to go through all of them, right? So you have the idea of how to get a proof. Yeah, so we established that the derivative of tangent is secant squared. So as it says, the derivative of the remaining 3 functions, cosecant of s, secant, and cotangent can also be found easily using the quotient rule. So maybe let me write these down. So we know secant of x is 1 over cosine. So you can try these. If you want the derivative, you know, you have to attach the differentiation operator to this and use a quotient rule. Now, you know that cosecant of x is 1 over sine, right? So you know this. So you can use this to apply the quotient rule here and you get your answer. Cotangent of x is equal to what? It's cosine of x over sine. So you can still use the quotient rule here and you get the corresponding derivatives. Yeah, and that's it on that. Okay, so in the long run, we get this, right? So this is what we must, this is the takeaway. If you don't understand any of the proofs, at least you have to know these going into the exam. So the derivative of sine is cosine, the derivative of sine, cosine is, the derivative of sine is cosine of x, the derivative of cosine is what? Negative sine of x. The derivative of tangent of x is secant squared of x. The derivative of cotangent of x is negative cosecant squared of x. The derivative of secant of x is secant x, tangent x. The derivative of what? Cosecant of x is negative cosecant x, cotangent x. Right? So you have to memorize all these, but the pattern that I use here is this. You see, what is cosine? It's co of sine. What is cotangent? It's co of tangent. What is cosecant? It's co of secant. So technically, for the shortcut you can do here is you just need to memorize 3. Memorize sine, memorize tangent, memorize secant. And then their cos will be like the negative of the co. So what I mean by that is, if you know the derivative of sine is cosine, the derivative of cosine will be negative, so co of cosine. So kind of like the cos cancel out and you get sine of x. So negative sine of x, right? And then tangent is secant squared. The derivative of cotangent will be negative of the co. So that'll be negative cosecant squared. So that'll give you this one, right? Secant of x, the derivative of the co is what? The negative the co. So that would be what? For secant s, you have secant s tangent s. So the negative of the co will be what? Negative cosecant s, cotangent s. That's what I use, right? Okay, so you have to memorize these 6 rules plus the other 2 limits. I think it's 11:50. You just track 11:50. Let me see what's up here. Okay, yeah. So I'll end here. Yeah, so thank you for your time. Today's Friday, right? So yeah, I'll see you on Monday. Please feel free to reach out if you don't understand anything. And please start memorizing the rules as soon as you can. Don't wait. It might become overwhelming. Yeah. So all the best. See you on Monday. You're welcome.
Thank you.
Thank you.
Oh, that's Elwin Smith. That's Elwin Smith. Okay, guys, all the best. Yeah. Yeah, yeah. I think they're going to release one this month soon. Oh, really? I see. Yeah, yeah. It's a